This is Algebra 1, Chapter 6.4. Today we're going to talk about elimination again, but this time it's not by adding or subtracting. I told you guys yesterday that there's a better way than doing subtraction. I personally like to always add. And when we added, we always wanted to have a variable to have the same coefficient but opposite in sign. And so today we're going to learn a technique that we are going to be able to make that happen. You notice that these are the same 5 steps in black that we had last time from yesterday. But now we added a blue step in here. And that blue step is you multiply one of the equations or both of the equations by some constant term to get the two equations to contain an opposite terms, opposite coefficient on a term. Okay? I'll give you guys some time to write this down. So remember, the steps are, you want to put it in standard form. Once you have it in standard form, you will recognize that you're going to want to get rid of one of those variables. And therefore, we move to step 2, and we say, hey, we can't just add or subtract them this time, so now we're going to multiply them by some number. It's going to be 1 or 2 of them, and then we can add them. Notice that actually on step 3, I changed it from add, subtract to just add. I am going to force this to be a system where one's positive and one's negative so that they cancel when adding. You solve for the remaining variable, use that remaining new variable you found to find the remaining variable, and boom, we're good to go. So let's put this to practice. The first example, guys, I'm telling you, you only need to eliminate or multiply one of these equations to get it to eliminate. Now, I've said something before that you could use substitution for a system. We've already done that before, and it works. So I could technically solve for x. Solve for x in this equation, solve for y, or solve for x or y in the second equation, and substitute it into the other, and it's going to work. It will. But usually you get a system that looks like this, and you're like, man, there is nothing that I really want to solve for. Now, if I was forced to show my hand and say, I need to use substitution for this system, I actually would solve for this y. Why would I solve for this y if I had to? We're not going to do that today, but why would this y be the one that I would solve for? Because all of the other numbers in that equation are divisible by 2. Or in that case, negative 2. But I could then divide that. But if you notice, not everything is divisible by 6, or in this equation, not everything is divisible by 3 or 7. So therefore, substitution might not be the best option. So when I'm looking at this, though, notice that it's already in standard form. The x's over the x's, the y's over the y's, numbers over the numbers. Do you notice there's something I could do to these equations? Now, I said earlier about dividing. There's no dividing, okay? We're not going to divide. First of all, you can take all division and turn it into multiplication by multiplying by the reciprocal, okay? So technically, could I multiply both sides by a half? Yes. Could I multiply both sides by a fourth? Yes, that's the same thing as dividing by 2 or dividing by 4. Generally, when we're doing this, though, I try to make things larger, not smaller, to make them equal. It's just a little bit less to think about. Now, next year, or as we get further along, and you start to realize more stuff, then go ahead. If you see that you can divide or multiply by something like a half to get rid of it to make it equal, then we'll start doing that. But for us at this level, we are going to stick with just multiplying by nice integer values, okay? So, looking at this system, which variable do you guys want to get rid of? And why? The x's or the y's? The x's. Well, do you guys notice that the second equation is 3x, the top one is 6x. So if I multiply the second equation by 2, I'll get a 6x. Well, here's the problem. I don't want them to be the same. I want them to be the opposite in sign. So I'm not going to multiply it by 2. I'm going to multiply by
Negative 2.
-2. Now, this is how we do this. We multiply the second equation by -2, which means I put a set of parentheses. Because technically what I do to one side, I am doing to the other side. In this case, now that I have a -2 outside this big set of parentheses, in my mind, I now know I have to distribute. So what's 2? -2 times 3. So -6x. -2 times -7. So it's plus 14y. And -2 all the way. Don't forget that last one. A lot of students do, but don't forget it. What's -2 times -19?
38.
It's a positive 38. And then what I will do is since I did not touch the first equation, I'm just going to bring it along for the ride and place it underneath. Oh, it's a positive 10. And now it looks like what you guys had to do yesterday. And all I'm going to do is not subtract, add. Because if I add -6x and 6x, they go to 0. They disappear. They cancel. They are eliminated. What's 14y plus a -2y? 12y equals 48. Divide by 12. Y is equal to 4. Right, not behind y, but in 4y. So now this is exactly what you guys did yesterday. Now here's the thing. Would you guys agree that our original two equations are the same as these two equations here? They technically are, even the one that you changed, because you didn't really change it. You did something to both sides of the equal sign, so it's not really different. If you were to graph these two equations, the one that you changed and the one that you have now gotten from that change, you would get the same line. Okay? So, we need to take the y equals 4 and we need to place it into y, into one of these top two equations. So, choosing the top one, okay. So 6x minus 2 times 4 is equal to 10. Or 6x minus 8 equals 10. Add 8, yes? Okay. And therefore it becomes 6x equals 18. Divide both sides by 6. X equals 3. Now you have a point. What is that point? It is the first one, but usually when we're working with x's and y's, I think we'll always put it x, y. So the point is 3, 4. And of course, the astute student will check it, yes. So example 2. I'm telling you this time, we're going to have to multiply both equations by a number to eliminate a variable. Okay? And so, we can get rid of the x's or we can get rid of the y's. Notice that on this situation, I don't even think substitution would even be a good option. Because nothing in the first equation is divisible by 5 or a 3, or like not all of them are, sorry. And in the second equation, not all of them are divisible by 5 or 2. So therefore, I would use elimination. Plus I am telling you we're going to do that anyways. Now, the whole idea, if I want to get rid of the x's, is to have a number that 5 and 2 both go into. Or if I get the y's, a number that 3 and 5 both go into. And that's what you would try to aim for to make. So what number is 5 and 2 both go into? 10. So that means I want it to say 10x and 10x. So actually not 10x and 10x. One of them should be negative. So your choice of which one you want to make negative. So the question is, what should I multiply the top equation by?
2.
By 2? Okay. What should I multiply the bottom equation by? Negative 5. Doesn't matter if you put it in the front or the back. I'm putting it in the back because the screen kind of cuts off the front half of the equation there. So I just have to distribute it through. I needed one to be positive, one to be negative. So 2 times 5x is 10x minus 6y equals 12. Is everybody okay with that?
Yeah.
Then I just distribute the negative 5. Negative 10x. Negative 5 times 5 is minus 25. Y. And negative 5 times negative 10 equals 50. Now I can add them together. Those are gone. What is negative 6 plus a negative 25? Negative 31 equals 12 plus 50. 62. This is not so bad. Divide by negative 31. And then everybody hopefully knows that y will equal negative 2. Now I'll just plug it in. So let's pick the first equation again. 5x minus 3 times negative 2 should equal 6. Negative makes a positive, so this is 5x plus 6 equals 6. Oh. If I subtract 6, I get what? Oh, so 5x equals 0. Oh, that just means x equals 0. Well, that's not so bad. So what's the point? 0, negative 2 is our answer. Why did I leave so much space on the side? You don't have to graph it.
Check it.
We could check it. Or, just for fun, let's get rid of the y's instead. Yep. Let's just do the y's instead, just to show we should still get the answer of 0, comma, negative 2. So if I wanted to get rid of the y's, wait a minute, guys. The y's are the ones that I actually would have chose to get rid of. Why? Why would I have chosen the y's instead of the x's in the very beginning? What's so special about those y's? They're not the same. What's that?
One's negative.
One's negative and one is positive. You guys notice that? I don't have to work with negatives then. So, what's the common number between 3 and 5? 3, 5 both make a 15. Interesting. Okay, so I'm going to multiply this one by 3 times what is 15? 5. And 5 times. Wait a minute. Is there some connection? The numbers we had on here before was a 2 and a 5. And now it's 5 and 3. So you're saying that if I just take the numbers that are in front of the variable I want to get rid of and just multiply by the other equation by that coefficient, I'll have the number. You guys see that? Here's an example, though, of a time where I wouldn't want to do that. What happens if I wanted to know a coefficient of 24 and 36? And I wanted to cancel those, okay? We're going to put the solved problem on the side. This is a sidebar. 24x 36x. How do I cancel those? Do you guys really want to do this? Take this equation and multiply it by 36. Take this one and multiply by negative 24. That's a pretty big number, isn't it? You could use a calculator, that's fine, but that's a really big number, right? There's got to be a better way. So let's think. 24, it'd be 24, 48, 72, right? 96. But if I start at 36, then I go to 72, and then 108. Oh, wait a minute. They both run into 72. How many times did it take before I got to 72 with 24?
2.
1, 2, 3. 3 times 24 is 72. 36 times negative 2 will give me a negative 72. So basically, guys, we're not just multiplying by the opposite numbers. We're going to multiply by the LCM, least common multiple. What number do both of our coefficients go into? That's the one we want to go for, okay? Now that that's done, let's go back to our problem. So, what is 5 times 5? 25x. 5 times negative 3 is minus 15y. 5 times 6? 30. 3 times 2x is 6x. 3 times 5? 8. We engineered that to happen, didn't we? And 3 times negative 10. Okay, these cancel. Oh, wait. 30s cancel as well. That's 30. That's a bad 3. 31x equals 0. 31 times what is equal to 0? X has to equal 0. Hey, that's what we got last time. But now I've got to plug that back in, right? So, we'll pick this bottom one. So 2 times 0 plus 5y equals negative 10. Well, that's gone. Divide by 5. Y is equal to negative 2. All of that is supported right there. It is negative 2, which is supported to 0, negative 2. Both ways work. It doesn't matter which one you get rid of first. You're going to be happy with the result. Okay? Homework, page 367 through 17, odds. Have a fantastic day.